Good morning and welcome to the Red Couch live here at PCIM in Nuremberg. My name is Michael Brunn. I'm the editor-in-chief of E&E, The Fascination of Electronics. And during the whole trade show, we will talk with important people from the power electronics industry about topics that are moving the industry right now. And you can watch us here live at the trade show or via YouTube or our Facebook channel later on. And now I would like to welcome Aengus Murray, Motor and Power Control Applications Manager from Analog Devices. And we will talk about key design challenges in motor control and digital power management. Welcome, Mr. Murray.
Thank you.
Great to have you here. When we're talking about key challenges, isn't it all about energy efficiency at the end of the day?
Yes, it has. and maybe that's a simple answer, but it has been for a long time and it continues to be. And it drives everything, I think, in the industry. So it's not just about efficient motors, it's about efficient control, efficient power conversion, and it drives all aspects of the signal chain. And the customers are leading, our customers are leading with efficiency. And so you will see over the past number of years, there's been a transition from simple open loop control to closed loop control that immediately drives up the processing requirements, current feedback requirements, even communication requirements. So when someone's looking at improving the efficiency of the plant, they're not looking just at making a more efficient motor. It's more efficient operation of the robot, that's faster dynamics, more efficient utilization of that plant. So they have communications between machines to optimize the usage. So we see it driving everything. So our end customers are asking for more processing power to do better algorithms. They need to be able to run permanent magnet motors instead of just induction motors because they're more efficient. They want more compact electronics to improve the space efficiency, faster dynamics so they can improve the motion efficiency. So it's at multiple levels. And they're continuously pushing. And when you go to the power conversion, it's a similar story. It's more efficient switching, faster, less energy.
So one of the important aspects in motor control, of course, is sensing. And how can you make sure to provide the most accurate position information?
Position information, yeah, it's in motion control. That is the most important thing. What we see customers doing is in encoder feedback. They don't, an encoder produces a pulse stream. The raw output from an encoder is actually looks like a sine wave. So very many of our customers are sampling the encoder, the sine wave outputs, and interpolating between the zero crossings. So you will find a 1,000-line encoder can produce 16-bit or 18-bit information by adding a converter in front of that. So you will find a number of our customers are using our converters with some digital electronics to produce very high precision feedback that is used for very accurate speed control in robotic systems, very fine position control in precision servo drives.
What about MEMS sensors? How important are they in motor control applications?
MEMS is in some ways game changing. And where we see it been used is supporting the safety aspects of the system, also getting a different kind of measurement. So a MEMS sensor directly measures acceleration, but when you combine that with gravity, it also measures angle. So if in a robotic system, a number of customers are, you want to have, you want to always know where the end of the robot arm is. You always want to know if the load is in the right position, and you're relying on that robotic feedback system, the angle from the different elements in the robot to tell you where the end system is. But if you put a MEM sensor at the end of that arm, you can immediately tell, okay, what angle is this sitting at? It's an extra piece of information, an independent path, because the biggest concern with with safety of systems is that the weakest link is your problem. So, so you need to measure, you need to make sure every angle measurement in the robot is exactly right to tell you exactly where the end piece is. And if you have a robot that's holding a very heavy object, like a car, for example, in automotive assembly, if that's not exactly level, you have a MEM sensor can tell you immediately, okay, there's something wrong here. And it's this independent path to confirming that the rest of your system is okay. Other aspects is in diagnostics. Say you can measure vibration. So if your motor has some bearing problems, you can detect the vibrations in the motor and detect the signature vibration for a problem in bearing. So there's multiple areas where people are using MEM sensors in a completely different way to the traditional way of measuring what's going on in a motor system.
What can engineers do to meet isolation standards and regulations?
So isolation is probably one of the biggest challenges in the motor drive system beyond the power control part of it. You must meet these standards. The problem with traditional approaches to isolation, optocouplers have been very commonly used, but you're compromising performance in some way. The optocouplers have wear out problems. They're not the fastest devices. So at Analog Devices, we've developed a technology that delivers the isolation, but without any compromise. So you can get high-speed isolation through magnetic coupling without the problems you have in terms of the slowness of some of the optocouplers. And you have something that's very robust. You have two magnetic coils. There's no wear out in these coils. And then, of course, you have to deliver that in the packages and with the qualification testing on these components. So from the engineer's point of view, he needs to be able to select a component that delivers the function, like isolated conversion or isolated gate drive or just digital signal isolation, but meets all the specifications. So you have to meet the safety standards with the isolation voltage levels required by the application. And in motor drives, you're dealing with quite high voltages as you go up to the higher power levels. So you can have devices that need to be isolated up to 5 kV RMS surge. Your operating voltages are up to 600 or 700 volts. And that puts a lot of demand on packaging and also the isolation material. So what our customers expect from us is devices that have a stamp of approval from the safety agencies, so they know they can use it without any concerns.
Let's talk about the processing of data. What are the challenges here, and what are the solutions?
So, challenges. I will say in some aspects, life has become easier because. There was a time when engineers were poring over assembly code saying, how can I squeeze the lines of code down because I only have 10 megahertz of processing or 5 megahertz of processing for what I can afford to put into this drive. Now you have almost all the processing power you want. But the challenge now is, how do I do this efficiently? And there are many customers we've gone into where the engineering manager is saying, well, I have this group over here who've developed this very high performance drive. And this group here used to be able to do open loop control, but now they have to use sensorless controls, field-oriented control algorithms that belongs to this group. But how do I get the technology and how do I transfer this knowledge to these people here? So people are looking for flexible systems. So it's not about, just give me more MIPS, but how can I have it in a form that I can transfer this between groups? How can I share it across groups? So they're looking for, flexible processing systems, scalable platforms. So an algorithm that I can run on a very high-end processor that's doing a server drive and bring it down to a lower performance processor. I need tools such as Simulink. I need to be able to simulate algorithms and then bring it immediately onto the processor. So what we're seeing is a demand for more integration of the tools, easier ways to go from an algorithm that's working in the lab into an algorithm they can prove in the system. So it's more about the tools and integration of system tools with the development tools than just the raw processing power. Second aspect is in the motor drive system you have some unique interfaces. You're driving a pulse width modulator, so you have timing functions for that. You've current and position feedback, so you need to have interfaces for encoders, interfaces for current sensing, integration of analog conversion. So in motor drive systems, you need to have all this processing power that's available, but combine it with the right set of peripherals. So you have devices that give you everything in one chip. And that's what I guess my role in the analog devices organization is helping drive that integration of what's the right components for motor control combined with our processing capability to give a solution for the drive customers.
So what about communication solutions? Which ones are the most suitable for motor controls?
That's a very good question because there's probably over 30 or 40 communication protocols.
You shouldn't explain them all right now. It would take
not
a
even
little bit too long.
And the challenge is actually how do you manage all this? And there's many different solutions. Typically you will have a separate processor for the communications protocol, so there's gate array solutions for that. So we support that through what is driving processor requirements. So you'll find now that the drive interface is not just a simple analog reference, it's now a serial bit stream on one of the protocols. So that's driving our processor requirements. But the other aspect of this is it's not like a home network where you have a very tame system. You're now trying to put a communication system that has to behave well with sitting next to an inverter switching 600 volts, with 100 nanosecond rise times, injecting a lot of noise. So we are focusing a lot on the robustness of the communications interface. So someone has a protocol that works on RS-485, for example, but this transceiver has to live in an environment where you may have 15 kV lightning surges injected into the system. So it's about robust communications in motor drive systems as much as protocols.
So now we have the perfect hardware, we have the tools, we have the robust communication. So we should have the perfect motor control. Is there any chance to make motor control even better?
Well, of course we believe we have the perfect system, but none of our customers ever accept that, because none of their customers will ever accept that. So there is a continuous push for improvement. And everyone is pushing for lower cost, but it's not just a lower silicon cost, but it's a lower system cost. Some of the trends we're seeing, and it's, for example, the more efficient power conversion is now enabling more compact power stages. So you're seeing control now moving into the back end of motors. So you have drives with integrated control, and that's going to say, customers are saying we want more compact control, more functions in the same silicon. The expansion of networking and more network protocols and faster communications and drive systems is pushing more requirements for more processing power. Improved efficiency is pushing, even better accuracy in current feedback measurement. So there's always the push for improvement. I think faster, better, more efficient is still, as I said at the beginning, it's all about efficiency, and it continues to be. And until you get 100% efficiency, no one will really be happy. So that means we're never done.
Thank you very much, ladies and gentlemen. This was the Red Couch talk about key design challenges in motor control and digital power management, live from the PCIM trade show. Mr. Murray, thank you very much for being our guest this morning. Thank you very much for watching and listening. We wish you a successful trade show, and if you are interested, you will find this interview and all the other Red Couch interviews on Publish Industries' YouTube channel later on. Thank you very much.
Thank you.